Doesn't work yet. No, it doesn't. All right. Good morning, good evening, good afternoon, everybody, and thank you for joining this episode of our workshop series, our training series, happening in spring of 2024. This episode is covering mastering Neo4j deployment for high-performance RAG applications. If you don't know what RAG means, it means Retrieval Augmented Generation. So talking about Gen AI, talking about how to connect AI applications, LLMs probably in particular, with a knowledge graph to work on that and to make more and better insights out of the connection of the two. But I'll let the pros talk about this today. But before we dive in, I think we need to do a little bit of housekeeping. This session will be recorded, so if you want to check it out afterwards, if some things went a little bit too quickly, if some things were not quite clear during the run-through, then you can always watch it again. We will share the links to this video to you all afterwards. We will also share the slides that will be used today as well in the link, so you can check that out afterwards, again, in your own time. If you have any questions during this sessions right now, then please use the Q&A segment. We have, obviously, I'll have an eye out on it on your questions, but also Alison and Jennifer from the developer relations team are in the chat as well, and they look out for your questions and try to answer as much as possible. So please don't be shy. Ask any questions you have, any remarks. If anything is just not quite clear, or if anything doesn't make sense to you, then just type it out, and we'll try to make, either during the session or afterwards, take a little pause here and there and try to look into questions so as we come along. What else is there to say? Keep the conversation going. I wish you all good time. Enjoy the session, and maybe quickly handing it over to Daniel, Alex, and Alex. So it's like a lot of Alexes here in this in this session.
There absolutely is. So great note. Thank you very much. Yeah, there's a lot of Alexes. Why don't I can go ahead and just share the slides and we can jump right in. Does that sound good?
That sounds good. Yep, perfect.
All
cool.
Right. All right, how does that look?
That looks great.
All
I think that's really good. I'll hide myself, get myself out of the way, but I'll be popping in every now and then again for if there's breaks, if there's questions, if for anything else. But yeah, enjoy. Have fun, everybody.
No, perfect. Thank you very much. And hello, good morning, good afternoon, everyone. Thank you for joining us for this this session where we're going to be talking about taking a Gen AI app from proof of concept to production. I'm joined by my colleagues Alex and Alex, and really quickly, I think, but before we jump in, we can just quickly introduce ourselves. Mr. Gilmore, do you want to start?
Yeah, sure. So my name is Alex. I'm a consulting engineer on the professional services team at Neo4j, located in Chicago. And I focus on primarily Gen AI applications.
Alexander?
Yeah, good stuff. Hi, everyone. My name is Alexander. I'm a pre-sales engineer in the central US. I'm based out of Phoenix, Arizona. And yeah, my job is primarily working with customers to prove out the value of Neo4j. And I work on quite a bit of Gen AI opportunities as well with different customers and different, verticals and use cases. So excited to talk to everyone today.
And my name is Daniel Bukowski. I'm also a pre-sales engineer here at Neo4j, also based in Chicago. And just like Alex and Alex, working on a lot of graph data science, Gen AI, and similar use cases with our customers. And so we're excited to share both what we've learned, in working on this application, that we've had going for a couple of months now, but also it also leverages some of the general insights that we have from just working with and speaking to a lot of customers who are experimenting with Gen AI, with Neo4j, and kind of what we're seeing, in the field, in addition to what we've learned by building this application. And so with that, just a couple of key topics that we're going to focus on, throughout the session. And, I want to give Alex credit for thinking about kind of the stories or the themes that we'll carry through. And a lot of this is, it's what we're seeing with working with our customers. They've been experimenting with Gen AI apps, especially during 2023. But now that the calendar's turned over and we're actually almost at the end of Q1, what are they doing to take that experimentation and make it something meaningful, make it something that can be used by more than a handful of people who might be working on it? And that's the similar journey that we've gone on. And so there's a couple of high-level themes around. We built the POC in notebooks, but then we moved on to Streamlit, or kind of a front-end hosted library, and then fairly quickly moved off of it because we saw there's other needs that we had. What have we done to enhance the backend and the data engineering pipelines, as well as how is the actual data for a RAG app evolved, and the data model for how we're building that out in the knowledge graph and persisting documents and pieces of text and questions, and then wrapping that all together with logging both with Neo4j and with third-party tools, and how important that is. And it's going to be, especially going forward with some of the new regulations. And so with that, there's, we'll definitely revisit this at the end of the session, but a couple of key takeaways. And what we've, as we were putting this presentation together, really thinking about what have we learned through this process, and what have we seen, others working as well. It starts with really work towards building a viable app, not only for today, but for tomorrow. A lot of, ourselves included, but a lot of people are experimenting with Gen AI and what can I do to, chat with my PDF or maybe bring in some internal documentation. It's great to start, my background's data science. I love using notebooks, but they have limits. And so, quickly when you see that you have something, you want to move toward a viable app, something that you can scale and share beyond the immediate team. And then that real world usage is critical. And so get the app to a point where you can get people using it, probably going to be internal to your team or to your company, but get other people using it, get a fresh set of eyes to ask it questions, see where it does well, see where it doesn't do well. And then as part of that, obviously we're with Neo4j, but we are really seeing that knowledge graphs are key flexible elements of this overall infrastructure. We're seeing with our customers where they might have started with a vector database or something else, but they're not getting the answers that they think they want. But when you incorporate a knowledge graph, you can get much more accurate, complete information from that grounding data set, whether it's documents and text-based like we're showing here today, or maybe a real-world digital twin, or kind of a graph that reflects an actual network, whether it's an IT network, a logistics network. Having that information gives you, having that in a graph gives you much more accurate, complete information. And then just the importance of logging the usage. Again, we'll dig into that more, but not only to see where the app is doing well and where it's not, but also to learn and figure out what you can do to improve as you're, let the logging, let the results, let the feedback drive your development going forward. And then also gives you visibility into the LLM responses. And this is just like as with the regulations that are coming, this is going to be critical moving forward so that you can see how did the app do well, and if it's in a production setting and there's going to be potential real world impact from the responses, if you don't get the answers you want, how did that happen? Why did that happen? A lot of highly regulated industries, you have to log your ML pipelines, your ML models, and show how they're performing. That's going to be the exact same with Gen AI apps. And so be sure to build in a logging function to understand that app's behavior. And so we'll dig into a lot of these as we go forward, but these are kind of the key takeaways and the big lessons learned that have jumped out to us over the past few months. And so with that, we'll just jump in and get started. Just a real quick background on what we're building and kind of what we're talking about to frame the rest of the work we've done. If you joined us for Nodes back in 2023, Alex Gilmore and I presented on the Agent Neo app that we were building, and this is an internal tool that we built to help our colleagues working with the Neo4j Graph Data Science Library, which is a collection of functions and optimized algorithms to help you drive greater insights and drive analysis from your Neo4j knowledge graph. And so what we did was we built a RAG application that's grounded. It's It's a RAG application on an Aura instance, an Aura knowledge graph containing documentation from Neo4j, the formal documentation, blogs, and other sources. We built this using LangChain, and we quickly moved, as we'll show, from notebooks to a POC using Streamlit, and then kept the development going, and especially with Alexander and help from a few others, migrating it onto proper cloud infrastructure with a custom React front end and a lot of tooling to just give us the functionality that we would need to move this towards a production tool. And so, building this app on the grounding database of text in a Neo4j knowledge graph, this is what we're going to be talking about as we move forward, and kind of the lessons learned and the stories from the work we've been doing for the past couple of months. And so with that, we're going to jump into the first key theme, and then after we get through this, Alex, I think we can pause for questions. But this will be the first big block of lessons learned going from core notebooks to an app that's built on Streamlit. And so, as we mentioned, the initial POC was built across a couple of Jupyter notebooks, and that was when I really first started with this. When I first started working on this, I was building it in notebooks just so I could get that response right there. And it was just an easy way to test and quickly iterate. And it worked. It was fine, but 4 notebooks is not a production app. You do not want to run production apps from notebooks. I think everyone knows that. And so wrangling these notebooks and managing change control was unpleasant. And the only way to actually use this very, very early skeleton of the project was to actually load the notebooks, run them, and ask the question and get the response in the notebook. And so, Alex, I don't know if you want to jump in, because this is about where you got involved in the project and really helped us get out of this notebook-driven mess.
Yeah. So, I mean, like you said, I think pretty much every project starts here. And if you haven't started like a project yet, I think it's important to keep in mind like how you're structuring these notebooks, and like keep in mind like how these are, like what kind of components are really at work here. And then we can maybe move to the next slide to kind of go into this a bit more. So like you saw before, we kind of had just like a notebook cell with a bunch of text making a call to an LLM. And so here we have on the side, you can see we kind of like took that and put it into like a class that just kind of handles like the initialization of an LLM, and then handles the code to like get a response and the context handling. And this really helps just maintain consistency and robustness in your code. And when you're moving from like a notebook into Streamlit, something else that you really want to pay attention to is like what variables do you want to like adjust and like fine tune. And so this could be like the temperature. This could be like the number of context documents that you're returning. It's also the LLM that you're using to generate these responses. And so what we did is we chose a couple of these and put them in the sidebar so that users that were engaging with our application could choose different parameters, and then at the end of the day, provide feedback on the responses that they were receiving, right? And so this really helps you, other people are doing the work for you of like fine tuning this, because all you have to do is look at the results of, what temperature works the best, or what LLM is providing the best responses. And it really helps get you into that production state a lot faster. And Streamlit is a great infrastructure to use for this, because it handles a lot for you. And so Dan, maybe we can go to the next slide here.
Yeah, and I'll add one little quick note around like kind of what Alex is talking about. If you have a software engineering, software development background, this is probably common knowledge, but we don't. And that's like, my background, I didn't even start in technology, but moved into data science. And so, these patterns, which are pretty straightforward from that type of background, like there's a lot of people we're interacting with, and I'm interacting with, who aren't software engineers and don't have that type of development background. And so this is kind of encouragement to, try to bring in those best practices, or bring in someone who has those best practices if you need to accelerate it, because the way you do experimentation in data science and data analysis and other related fields, isn't necessarily a best practice for building a production app. So it's been an education for a lot of us working on this.
Yeah. And so here you can see like what I was talking about with like the parameter selection, and you can like Streamlit really is user friendly in the sense that like you can even like provide like tooltips, like let people know like what these parameters are changing. It's a very friendly layout. And something else I didn't mention is that like Streamlit will host your application for you. And so it takes away all of the like network engineering and cloud knowledge that you may need to get your app up and running. It's easily shareable, and this really just goes to like expanding your user base and collecting all of that data that, like here we say, like tells you how are users actually going to use your application at the end of the day, what parameters are most useful in getting those answers that you need out of your application. And then when you eventually take the Streamlit app and then refactor it into a production app, like you know what you need to put in place of those parameters. Is there anything? Yeah.
Do you want to keep going?
Yeah, we can move on.
All right.
Yeah, so once you have your Streamlit app built and you've shared it with some users and you've collected some data on it, it's probably time to move on into a self-hosted option. And there's really a couple of reasons why we may want to do this. We'll go over the challenges here of, Streamlit is very difficult to deploy if you're not using Streamlit services. So to deploy this on a cloud service like GCP or Azure, it can be time consuming and not exactly clear. You also need Streamlit deploys off of GitHub. And so if you are building a private app or you're working in a company and you're trying to get a POC off the ground, you may need Streamlit to have access to that GitHub repo. And that may provide or may cause some security issues within your company. They may not want that to happen. And then also Streamlit has a very nice but strict styling. And so if you want to introduce some custom styling or make this look like one of your company's products, you'll need to eventually move off and create something in React or another framework that can represent your what you're going for. And although Streamlit does have its challenges, like I said, it does have a lot that it manages for you. And so Streamlit is a Python application. It handles all of the HTML, all the JavaScript for you. And that's abstracted away in widgets, which are just little Python calls that you can make. And so it also manages auto scaling and auto deployment from GitHub. It handles the styling, like I said, but it also handles authorization, which is really nice. So you can control who has access to your application, which we've been using to test internally and manage like who actually has access to our LLMs and make sure that we're kind of regulating our costs with this application. And then, like I said, Streamlit packages like all of these front-end components into very simple to understand Python methods that you can just plug and play in your application. So it's very nice, but going to self-hosted is a big lift, and we don't want to kind of downplay that, but it is also a necessary step to take to get into a production app.
Yeah, and what made it fortunate really for us was even the grounding data that we were using for this application was already public documentation. Like there wasn't anything that where, like Alex mentioned, security issues or there was private, kind of internal content that needed to be protected within the corporate firewall, kind of within the corporate setting. And so that did make it something that we could use without really any issues, because again, all of the grounding data to begin with was public documentation. But especially in working with customers who are building knowledge graphs and grounding data sets on very sensitive data, some of the challenges of leveraging Streamlit or leveraging Streamlit like, as in the most easy possible way, would just be a non-starter for them in their corporate security settings, as Alex mentioned. So that's definitely something to keep in mind. When it does a lot of things really well. Very serious concern if you're going to be using it in a production corporate environment.
Yeah, and this is just a simple graphic, demonstrating this movement going from Streamlit to a cloud service, and then splitting your app into these two components. And so we can go into the next slide, actually, where we kind of go into more detail of what this cloud infrastructure may look like.
Yeah, and I can talk about this slide. Yeah, so like Alex said, we made the decision to migrate from Streamlit and migrate to more of a React front end and a fast API backend. So we basically decoupled our Streamlit application and then migrated it over to those two technologies. These are kind of the core cloud services that we used when we actually got everything deployed into the cloud. So we started off by refactoring our Streamlit front end code into React code, right? So we took our Python code that we initially used to build the UI, right? That's what Streamlit's written in, like Alex said. And we moved that over to TypeScript and React. The reason for this was a couple of reasons. So one was the performance benefit we got from going to React. So with Streamlit, what happens? So Streamlit will manage all of its state variables internally, and state variables in a full stack application are basically variables that handle change on the UI, right? So anytime you make a change to the UI in Streamlit, it has to basically run the entire Streamlit script from top to bottom, which is not performant at all. React handles that much better. React has a virtual DOM that will actually update the physical DOM, right? So you're basically updating just like a small part of the UI instead of having to run the script top to bottom. So the performance benefit was something we were really interested in because, again, we're trying to scale this out, right? We started with, our application in Notebooks. It was headless, right? We moved to Streamlit, which was a great kind of proof of concept framework, right? Where we could demonstrate what a UI could hypothetically look like. And now we're trying to scale it out even further, right? And make something that might be more public facing and more optimized from that perspective. So that's point one, right? And the second point is React really gave us a ton of flexibility in terms of rendering that UI or customizing it, right? So we're able to leverage a really wide ecosystem of JavaScript visualization libraries. We're able to use things like D3 or we recently released a JavaScript library for visualizing graphs that we use in our underlying graph data visualization tool, Neo4j Bloom. So we're able to use those libraries, right? All these external dependencies essentially with React. So we migrated that. We constructed a fast API and we packaged both of these things in Docker containers. And we pushed, Docker images, and we pushed those images into Google Container Registry. Something to keep in mind, right, is this is agnostic to any cloud vendor, right? We use GCP, but you can run this on AWS, Azure, really whatever you want, right? And they all have kind of the same services that they offer. So yeah, we pushed those to the front end and the back end to the container registry. From there, we deployed those images to Google Cloud Run, which is a serverless service essentially that can run those two images. So we're hosting those images through Cloud Run. Within Cloud Run, we're hooking into Cloud DNS to basically create a pretty DNS name for our application, and that also handles all of the SSL. So again, just kind of security, just boring security things, right? We're implementing for our now cloud application. And we're also on the side here, Fast API is talking to our LLM. It's talking to Neo4j. We have Airflow, which is running kind of on the side as a sidecar with our data pipeline. So there's a lot of stuff going on here. But if we move to the next slide, Really, the key thing to keep in mind is there's only really 2 services that you need. So if there's like any sort of recipe that you were trying to come up with here, like for the bare minimum to deploy a production application to GCP, for example, you really only need Cloud Run and Google Artifact Registry, right? So again, just build your front end application locally, build your back end services locally, package them in containers, and then, you know, obviously deploy them to Google Cloud Artifact Registry and Cloud Run. So pretty straightforward there, right? You really only need 2 managed services, and then the rest of the managed services are just like, you know, additional features, functionality, decoration, right? So yeah, I mean, pretty straightforward there. I think really the key thing is like we started off in Streamlit, right? We were doing a lot of this stuff, you know, hosted locally, and then we're trying to move all of that into the cloud and scale it as we go. I guess we can move on here.
Yeah, and also just again, I was going to highlight again that you know, as you mentioned, this is cloud agnostic. Again, we built on GCP, but you know, as Alex mentioned, any of these services, you know, these services are available on all of the major clouds. We're just highlighting what we used, just in this case because it was, you know, it was what made sense for us in our building.
Yeah, so I talked a little bit about this already, like why we decided to move from Streamlit to React, right? And I kind of walked through, yeah, a couple of these points already, like the greater degree of decoupling between the back end and the front end. You know, going from Python to TypeScript gives us, you know, type safety, allows us to catch more bugs, and then yeah, like the performance and just the level of customization you get with React. Something that we leaned on heavily was our Neo4j needle design system. So this was a really awesome asset for us to basically create like a beautiful Neo4j-ified UI. So the needle design system is basically a styling and component library that we have developed. So again, it allows you to create a very like Neo4j-ified UI, and we did a lot. We wrote a lot of the code for you, right? So it's like, you know, you're able to basically import this code that we already wrote, and you just basically have to assemble it, right? So it's a lot less coding and a lot more like building blocks, essentially. So I guess background, like I did some of the front end work. I'm not a front end engineer by any means, right? I would definitely consider myself more of a back end guy, but I was able to kind of figure this out pretty easily. So I feel like, you know, customers or prospects or anyone that's looking to build kind of a Neo4j RAG chatbot should be able to build a React UI with, you know, maybe over a weekend, right, using this needle design system library. It really, I think, accelerates the UI development from the React perspective. Yeah, so that's what I guess I had there. Alex, do you want to maybe talk a little bit about the Streamlit to Fast API?
Yeah,
migration
yeah,
you
sure.
did?
So yeah, so we broke up our Streamlit app into 2 components, right? Alex spoke to the like front end using React, and then the back end we wrote in Fast API. And this was really nice for us because it's super easy to develop a backend using this infrastructure. It allows you to validate your requests and your responses, implementing Pydantic, which we can talk about later. We also are able to perform logging in the background instead of running it, you know, in line with our LLM calls and all the other processes that we have going on in the Streamlit app. It also provides automatic documentation, like you can see on the right here, which is really nice because as your team expands, well, like our team really just started with Dan. And then, you know, we kind of kept adding people. And so this automatic documentation is really nice so that everyone's on the same page. It's very accessible. Just lets everyone know like how things work. And then it's also stateless, which, you know, again, speaks to like decoupling the back end and the front end, allowing us to scale these services separately. And like that does introduce some other things that you need to address, like how do you handle like LLM memory and conversation history. But these are manageable tasks. And at the end of the day, it's we found that this is a better architecture for our application. And so Fast API uses Pydantic, which is basically, it's like Python with advanced type validation. And so what this allowed us to do was to do some heavy validation of the incoming requests. So we were able to make sure that we were getting exactly what we needed to send to the LLM, since anyone who's used LLM services knows that like the information that you feed into there can drastically change whatever output you get. And so by being able to explicitly define the input parameters, and then also being able to define like what we receive out of the LLM and then return to the user is incredibly valuable. And again, speaking to like, as your team grows, as more people are involved in this project, maintaining a very explicit and consistent set of these like requirements is very important. And like, I mentioned that we did logging in the background of our application, which we'll talk about logging in the back end of this presentation. But what we were able to do with Pydantic is also represent the nodes that exist in our graph where we're logging. And so being able to like define a schema for our graph in the back end so that we know how our application is supposed to be interacting with our graph at the same time is also incredibly valuable. And it's something that, it's difficult and not exactly rigorous if you're using some other library, or if you don't even have like a validation library in Python, because there is no actual type validation without Pydantic. And this kind of goes back to the front end. This is what our end result looks like here with our self-hosted application. You can see where it mirrors our Streamlit app, where we have like the LLM selection and the temperature selection. But overall, it's a clean design. It looks like a Neo4j application, right? It still has all the same functionality as before. So Alexander, I don't know if you wanted to speak to anything else on that I may have missed with the front end.
No, I think you captured that well.
And so real quickly, it looks like, we're kind of at a good spot. We're about to kind of move from, the front end and kind of moving from notebooks to Streamlit and then to a self-hosted. Alex or Allison or Jennifer, are there any questions or anything we should pause right here real quickly before we move forward?
Yeah, we can look at a couple of questions. I saw one from Neil. Said very, very exciting to get this going. Will node creation and dataset loading be covered in this workshop today, or are we more talking about general architecture today?
Today's going to be a little bit more about the general architecture and kind of what we did for moving from the initial POC to a production app. What I would suggest, and this is something that we'll point out later in the presentation, is the Neo4j Labs website for the GenAI ecosystem, where there's a really good demo there, an end-to-end demo of creating a knowledge graph from unstructured or semi-structured data, and actually kind of moving it, from, actually they use Streamlit as well. So there's a really good example there with code available on a GitHub repo. I would also suggest Tomasz's, a lot of his blogs and his content around using LangChain, where he has some really good examples of generating using LangChain, which we would definitely recommend, or kind of another orchestration layer of your choice, to take the raw data and move it into a Neo4j knowledge graph. For a similar, not to self-reference, but also the session that Alex and I did back in October, I think it was October 2023 for nodes, around, that was really the initial creating and building of this project. We actually pointed towards a GitHub repo that has the code that we used initially. This is I hate talking about it here, but it's the original ugly notebook code is there to for how you would actually take the unstructured or semi-structured data and convert it to a knowledge graph. And so while we're not talking about it today, I think those would be the resources I would go to start. But definitely start with the Gen AI ecosystem page on Neo4j Labs. We have that referenced in the last slide of the deck, and I think we can put it in the comments of the YouTube as well.
Yeah, I'll put it in the comments. I put it in the chat after.
Yeah, I think I tell everyone I talk to about Gen AI about that page. They've done such a great job with it.
Yeah, cool. I'll link to that. And I guess Ed asks, it's very helpful. Will there be a dive into the actual LLM RAG part? I guess we're getting to that.
Actually, it's going to be kind of a similar question. We do get into that a little bit, but again, this is the developer lessons learned. I would probably give the same answer. Whereas the RAG part and the LLM part was, I would say, almost like in the predecessor of this session. And that's been, especially given how much that's changed in the past few months, I would again point towards the Gen AI ecosystem page, which, I mean, everything has been updated. I mean, even honestly, if we look back, probably the code we were using would need to get updated to the recent versions of LangChain, and just a lot. There've been so many changes even in the past 4 months. While we discussed it at a high level, the most up-to-date content and for kind of that specific piece of it would be in the demos and the related, like all of the LangChain, Llama Index, Haystack integrations on the Gen AI ecosystem page.
All right, cool. I'll link, put a link to that in chat as well as in the video description, so you'll have it available later on. Yeah. And yeah, I think with that we can continue.
Awesome, great questions, Alexander. As the backend expert, your show.
Yeah, good stuff. Do you want to? Yeah, cool. So yeah, I guess sticking with the theme of talking about how we progressed here. So we built our initial knowledge graph, right, with a collection of data sources. And this was all done in notebooks, right? So initially we started off with just our documentation, right? So we basically grabbed all of our documentation. We parsed that documentation. We chunked the documentation. We encoded the documentation as embeddings and then wrote that documentation to our Neo4j knowledge graph, right? From there, we expanded our data sources. So we've since that point, we've grabbed YouTube transcripts, we've grabbed source code, and we've grabbed a couple of other things as well, right? So we have a kind of a variety of data sources here and like a number of data pipelines that we're basically grabbing these data sources and encoding them after doing a bunch of post-processing, right? Encoding that data as embeddings into our knowledge graph. We decided to use Airflow to orchestrate all of this code, right? So our code was originally in notebooks. We basically modularized that code, right, and moved it into Airflow. Airflow is a Python DAG framework, or directed acyclic graph. So I think that's kind of interesting. It's a framework to organize your ETL pipelines that looks like a graph. So it was a great fit for this presentation, just for our use case. But you could use anything, right? Like this is, this is agnostic to your organization. For example, this was just our choice to use Airflow. But again, we use this to kind of manage our complex, data pipelines. Also allows us to orchestrate the pipelines, right? So these are things you need to keep in mind is in the notebooks, right? We basically, it's like a one-off run. You run your ETL, it writes it does all of those intermediary steps and then writes the data to the knowledge graph. But it's kind of a one and done, right? It's triggered by you. There's no sort of update logic on the knowledge graph. And yeah, it's kind of a very one-off thing. With Airflow, we're allowed to orchestrate that much more and make the associated kind of refactoring in the knowledge graph, right, to account for those updates. Yeah, I guess next slide here, Dan. So something I did want to talk about a little bit was chunking strategy. So I think that this is something that's pretty important So one of the intermediary steps there, as we go from our data source to the knowledge graph, is we grab our data source and we basically normalize that data source into a document. And then we take that document and chunk the document or split the document, right? Based on some sort of logical pivot point. So like initially what we did was we just took a fixed length chunk. So we said like every 200 lines of that document, basically split it up, right? And then we send that chunk to a model, a text embedding model, right, to create an encoding from that. We've since kind of evolved that model to more context-based kind of approaches. So if we could go to maybe the next slide here. Just two quick examples here, right? And again, we had like a variety of data sources. So I felt like these two samples were kind of like good examples, right? To illustrate that. On the left, we have some code, some Java code. And on the right, we actually have a text snippet from Alice in Wonderland, right? So like, let's just, create a quick mental model of what that chunking strategy would look like if we did the fixed length chunking. So on the left, maybe we chunked every 5 lines. So you could see we have 3 classes on the left. We have a school outer class, and then we have 2 inner classes, teacher, student. So if we chunked on every 5 lines, right, we might capture the top, the signature for school, the signature for teacher, and kind of those first 2 instance variables. But it kind of destroys the context of the document, right? That chunk doesn't make a ton of logical sense. That strategy might work a little better for the text, for that text snippet on the right, but you're still missing kind of some context, right? And that's because both of these documents have like a hierarchical metadata associated with them, right? So we ended up landing on a recursive chunking strategy, which would basically take this like the hierarchy into account, right? So on the left, our chunk might now be just the teacher and the student class, right? If we recursively chunk that. And on the right, maybe, we have a chunk per chapter or a chunk per paragraph, right? Whatever our separator would be. So it's just like a little thing, but it's something that could have really quite a large impact on the accuracy of your responses, right? Is this kind of these small engineering decisions you make as you go along. So yeah, just something we wanted to call out really quick, right? Just be judicious when you're thinking about how you're kind of transforming this data before you encode it, the embeddings as a knowledge graph, right? If we could move on here.
Yeah, and I'll just, if I could real quickly, just to add on that, like especially the approach and really the different approaches to chunking that's been an area that's really been evolving rapidly. And even when Alexander, I know you and I have, we've talked with a couple customers together, like there's so many different types of data that they're looking to use, whether it's a unstructured or semi-structured text knowledge graph or something that's a little bit more real world, that one of the key takeaways is try a lot of different things, and you will almost certainly need to use a different chunking strategy depending on the different types of data that you're going to incorporate. And so as Alexander did a really good job highlighting, how you handle code is completely different from how you handle, say, we'll call this unstructured text. But if like our colleague Jesus Barasa in the Going Meta series, he shows how you chunk legal documents or regulatory documents, which that's been a really common source content that we've seen with customers. And so those are documents with very rigid, very strict predictable structure. I know, Alex, you've worked on a project with a customer doing just that. And so these all take different approaches. And so that's, just always be considering and evaluating and evolving your chunking strategies, because it's definitely not one size fits all. Like we started really quick and dirty with one size fits all, but saw the flaws in that. And with Alexander's help, have moved to a much more appropriate, more sophisticated strategy. Great, and so I guess with that, we'll jump into the data and the data model. Alexander, any other questions that we should touch on before we move forward? Anything else in the chat?
I saw one more question here. Whether you for your schema for the graph, did you use a schema for that, or is it more of a, Martin says, chaotic graph?
It's a little column A, little column B. No, we're actually going to get to that right now. So that's a perfect question to
Cool.
tee up that
Great.
section. So,
Yeah, then let's do that.
Yeah, so this is where, I didn't even pay for that question to be asked right now. So the data and the data model. So to start with, as I was actually getting to, we started with a very simple data model. And this is just a simple graph data model that in a way uses Neo4j as a vector database. And that's not really something we'd encourage, but it does have that underlying capabilities, just like all the other databases on the market now. But that does, just using it as a vector database leaves more than 50% of the capabilities on the table. But when we were first just getting started, and this was last summer, so a lot of the best practices and the technology was still emerging. We had a text chunk or a piece of text linked back to the source document, and so and this worked for when we were just getting started. We had almost 1,200 documents from just official Neo4j documentation. We were pulling in developer blogs. We had public-facing articles and from the support knowledge base, as well as some of the data from demo GitHub repos, some notebooks, some additional content that's been built by myself and a lot of our colleagues in the field engineering org. So we brought in a bunch of different sources, which is a great use for Neo4j. It's a really good aggregator for disparate data sources, and started with a very simple data model. And this did work. We were able to demonstrate some really good value from a straightforward data model like this. But pretty quickly we looked at how do we want to expand? How do we want to expand the knowledge base? How do we want to expand the data set and what we want to put into this? And so when we first were looking at it, we're like, oh wow, we want to bring in everything possible. It's like a kind of a big data type approach of more is better. And so we wanted to see, can we bring in more code from public repos, as well as transcripts from trainings and other Neo4j YouTube pages. But then we realized, this could be an expensive task. This might be more than what we want to do. And so going back to what I really like is Andrew Ng, who talks about data-driven AI or data-driven development, where more is not always better. And so when we looked at the time and the cost, and we were using, if we're using a kind of a hosted vector embedding model, the cost is going to add up. And so is it really worth it in the grand scheme of things to bring in all of the YouTube trainings versus the ones that we just wanted that were going to be most impactful? And we actually brought in the Going Meta series and some of the YouTube presentations that we made from Neo4j for nodes going back 1 or 2 years, because we wanted to emphasize quality over quantity. What was really interesting as we built out our data model and started logging in the database was we could actually see which pieces of text and which source documents were being referenced most frequently by ourselves and the users that we shared this tool out with. And so we were seeing 10, 15, maybe 20% of the total source documents were ever even being used. And that's again from a small kind of alpha stage user base. But again, there was a lot of documentation in there that wasn't being used because, again, the focus of the project initially was on graph data science, but then it expanded to the broader Neo4j platform. And so it was an interesting learning of, we want to bring in everything possible to get the largest grouting database, but in fact, that really isn't worth it, versus taking a look at the usage, and really looking at the content and focusing on what would be most valuable for our users and how they're using the app. And so that led us to a little bit of the logging and the visualization, which we see here, where in addition to building out the original data model of just we have a document, or we have a source with a piece of text. As Alex was mentioning, we were able to use some of the backend code to start logging the questions and answers in the same database. And this is a really innovative use of Neo4j for not only hosting the grounding data set, but also being able to see how users are conversing with the graphs, or how their users are conversing with the LLMs. Because if you look at it and you see the image here, every conversation with an LLM is in fact a graph. As Alexander showed before, it's actually a DAG, a directed acyclic graph, where in this case, we have the data model where you have a user logs in with a session, and then if you move left to right, they have a conversation. And for us, this was one of the options in our application where you go in and you can reset the memory, or you can select, hey, I want to use GPT or Gemini or Llama or whatever LLM we have as one of the options. And then the user asks a question, and that's this first user question here. Hey, how do I configure the FastRP embedding algorithm? As that gets answered, we have the assistant here, which is kind of the under the hood term for the LLM response, and it references back to all the different pieces of context that it grabbed. And so you can see we have, in this case, we had 10 pieces of context selected, and it went out and pulled those pieces of data. And actually, when it was logging the conversation as the graph, it referenced to all these different pieces here. And you'll see the numbers. Those numbers are actually clusters or communities that we generated using graph data science community detection algorithms. And so what's really interesting is for this specific question, a lot of the reference documents, except for this one right here at about 7 o'clock, maybe 8 o'clock, all of these are from basically the same community. And so the first response from the assistant grabbed these 10 pieces of documents, and then the user asked a follow-up question, which again, we're just chaining them together in a graph, a follow-up question where there was another 10 pieces of context, where again, they are, you can see 5 of the same pieces of questions were referenced again, and then there were 5 additional ones. And this is a really common pattern we saw, where you have an initial question and maybe a follow-up question for more clarification. And so, being able to log and visualize the conversations like this was really valuable for us to understand not only the user behavior, but also how the underlying data was being used in the database to see which, we can go through and see which pieces of data are being used most frequently, less frequently, but it really opens up a lot of opportunities, as we were building the app going forward. And so with that, what we wanted to do as we were building out the data model was explore what are some additional, we'll call them like advanced RAG strategies. And there's been a lot of writing about this in the past, really 6 months, on what can you do to just optimize your grounding data set, whether you're using a knowledge graph or a vector database or something else. And there's a couple of themes that have really emerged. And one overarching theme is to separate basically separate the retrieval from the synthesis, the analysis. And that gets to the parent-child relationship. So if we go back to, I'm actually going to go back a little bit here. In this case, we have one piece of, we have one item linking back to the document. But actually, as Alex is going to show in a minute, you actually separate this out. So you might have you have the source document, you might have a larger chunk that has that context, and then you have a smaller piece hanging off the end that you use specifically for matching, so you get more nuanced responses. We also have topic summaries. Our colleague Nathan was working on this for the past couple of weeks, where you take the clusters of documents that are semantically similar, and whether you use the LLM or GDS algorithm, figure out which one, how are they related? A lot of, you might have GDS, you might have Bloom, you might have Cypher, you might have APOC. How are these related? And the LLM can then take a look at those and generate a summary that can then help when it's built into the knowledge graph, either for traversals to getting more accurate responses, or even just using for retrieval itself. And then finally, the questions. And these are where we have kind of 2 sources of questions. We can have, we have our log of questions that are being asked by the users, but then we can also have the LLM generate additional questions and use those for retrieval. So if I'm asking a question, it's typically 50, maybe as many as 100 tokens. You want to, if we have smaller pieces of text that we're matching on, it's actually going to be a lot more useful to match on a smaller piece of text versus maybe something that's 1,000 or 5,000 tokens, where you're going to get, the most important elements of that are going to get lost with all of the other text. And so what we're going to do is we can just go through a couple of the data models. And I know, Alex, is there something you can jump in here?
I think Alex has internet connection problems. And
okay. I thought he was back. Yeah, no problem. We'll keep moving forward. So Yeah, I think he was having a couple connection issues, not a problem. It has happened to me. So again, this is just a quick review of our basic data model where we have the source, and then we have the source, and then we have the document or the text or the piece of chunk. And this is what we started with. And you can see we have an identifier, we have the actual text itself, and then we had the generated embedding using, again, you can use OpenAI, Vertex, others. There's a lot of different or open source models available to do this. And so then this is where we kind of illustrate the parent-child use case, where we have the source, or kind of the source document. We have the source, we have the actual document, or maybe the larger piece of text. This could be 500 or 1,000 tokens, because it gives you that broader context. So it's not just whether it's a piece of code or a couple of paragraphs. And then you have the child, and the child is that very small piece of text that we match on. Again, maybe 100 to 200 tokens, which will be very specific. And so when we go for the retrieval, we match on the child document, but go back and grab the full parent document, because it'll contain that child information as well as everything else that goes with it. And this, I think it's really useful to depict this as a graph rather than some other format, because you can really see how the elements are connected to each other. Similar with the question matching. We have the source, we have the larger document, and then the question. And as we'll show, these are either the questions generated by the LLM or the most frequent questions we see when we're looking at the logs of our application. And then finally, the topic summaries. And this starts to get into the area of ontologies and adding even more sophisticated structures, which is on our roadmap to continue working on. And for more information about that, I would definitely point towards Jesus and the Going Meta series, which has several outstanding episodes really digging into this. That's where Jesus is really the expert. But we have the source, we go into the document, and then we have the LLM generated summary. And then that summary can actually link out to specific topics, which might be 1 or 2 words. We could have, say, we might have FastRP, embedding. We have a summary of the FastRP documentation, and then topics that could be embeddings, FastRP, vectors, anything that you would have that would be a related topic to the overall source and the overall documentation. And so what we ended up getting to with our advanced data model, you see here on the bottom, we're still logging the questions like we started, but here we focus on the actual, the chunk, the core piece of the text. It links to the source, which is exactly what we had before. And then at this time, we've implemented the summaries. And then we've also brought in the questions. We brought in 2 types of questions. We have the question from the LLM, and then you can see we have these new relationships here where the questions, we're actually looking at the user questions as well. We're in the process of implementing the broader parent-child, but that's part of actually reloading the entire database, because when we first loaded it, a lot of the text chunks were 500 or fewer tokens. We're actually going to make the text chunks a little bit larger because we have greater capacity from the LLMs. And that's something we get into with the looking at the logs. But once we have those larger text chunks for the retrieval, we'll then hang off the child chunks, which will be much smaller. Because right now, where we have a lot of text chunks that are in that 200 to 300, maybe as many as 500 length range, it doesn't really make sense to have much smaller text chunks until we actually do an entire refresh of the database. And so with that, that's the evolution of data and the data model. It's a big piece of the work that we were doing, and one that really leans itself towards Neo4j and building out the graph and the graph database. Alexander, Alex, is there anything else, any other questions we want to jump into before we move ahead?
At the moment, I don't see any questions, okay. So I think we can go ahead. Yep.
Okay, yeah, no problem. And so I think the last topic that we're going to touch on is going to be the logging and the evaluation. And this is one that, this is a topic that I have a lot of interest in and have been doing a lot of work on, and see as a key emerging trend for LLMs, Gen AI, and this entire ecosystem moving forward in the next, especially in 2024. And so even before we get into what we've done for logging, I definitely want to touch on just the importance of having this. a lot of the customers we work with, and we primarily talk with, kind of commercial customers across a lot of industries, but many in finance and other highly regulated industries. Especially here in Chicago, we have a lot of life sciences, pharma, finance, and others. But this is going to be key for any customer or any organization in a highly regulated industry, or an industry with a lot of visibility from governments and regulatory bodies. They're going to want to know, if you're using these LLMs and Gen AI applications in production, do you have good records? I started my career as an accountant and an auditor, and so on the financial side, on the IT side, you need to have and be keeping good records. On top of that, we're seeing new AI-specific regulations like the EU AI Act, which is already moving forward, as well as the proposed regulations here in the United States and elsewhere around the world. And so this is going to be, some sort of a logging system is going to be critical for production environments where these Gen AI app responses might have real-world implications. We've seen some funny ones like Air Canada, where the chat assistant generated a discount code that didn't even exist, but the airline was told by the courts, you have to honor it because your tool, your agent told the customer this was a valid discount code. Well, that's kind of a funny example. You can think about other use cases where it's going to get a lot more serious. And so just having that for the real world implications will be essential. On top of that, you want to be able to understand, what is your LLM doing? How is it actually generating these responses in a RAG context or as agents are coming into play? They had a little bit of a moment last year. Technology wasn't there, but now agents are really coming back. And so it's not just going to be generating an answer. It might be taking action on behalf of the user. And tools like LangGraph already designed those using graphs, and we'll want to be able to understand them also using graphs. And then finally, logs just help you understand how your app is performing, and then look for areas for performance improvements, which, as we dug into the logs, clearly jumped out to us on areas where we could get better efficiency, better cost management, and just make an overall better application. You really understand how your app is working when you dig into the logs. And so to do that, there's a couple of tools out there. There's Weights and Biases has their tracing app, but we have a really good relationship with the team at LangChain, and so we started using LangSmith. And this is one of the key tools that the LangChain team has put out. It's going to be part of their commercial business. And it's basically it's an easy way to log the actual units of work that are being performed every time you submit a question to your application. And so you can see here on the right, we're using LLM chains, we're using conversation chains. It actually gives you very, very granular logs on every single element that's being performed. And so it's developed by the LangChain team, but you actually don't have to use LangChain to use LangSmith. I think it was back in January or February, they had their major release of it. But yeah, it provides a lot of extensive logs, and they have a really good LangSmith cookbook on their GitHub repo that I know I use to just get a lot of examples of how to implement, query the logs, and analyze them. In fact, what I did is, they have the user interface on the website, but I actually pulled the logs into a notebook. I know we've talked about the notebooks have their limitations, but for actual data science type analysis, the notebooks were really useful. And I can see, pushing these logs into a dashboarding tool, into some other type of front end, or as we'll talk about, pushing them into Neo4j itself. So as we were digging into this, one of the key lessons were that there's a lot of low-hanging fruit, and even just starting with latency. Like this is something that we were seeing initially as we were asking questions to different, using different LLMs. We're using a mix of LLMs from different providers, different architectures behind them, different hosting behind them. So I'm not going to name specific names here, but you can see we have 3 LLMs and this is just a very small sample of our data. You can actually see by pulling that data into a notebook, generated a real quick histogram here and look at the statistical distribution. It wasn't just us. It wasn't just our users saying these records were taking, or these responses were taking a long time. We could actually see in seconds, wow, we have this LLM here is taking on average of 23 to 25 seconds versus the other ones here taking 2 to 3 seconds. Is that a configuration on our end? Is that a hosting issue on our end? Or is that something in how we're accessing or just the demand that might be on a certain LLM at a specific time? So this was an area that we dug into really quickly and were able to improve the overall latency, because when you're asking a tool for a response, your users aren't going to want to wait 20, 30, even 50 seconds for the response. And something that we also saw that was, there is some correlation between the response time and the amount of context, the tokens, the number of documents that are provided as well. There's more processing that the LLM needs to perform, which can add to the latency as well. So, but the good point of all of this is that, when we're grounding on a Neo4j database, all of those hits were always fractions of a second. And so, we actually do get that question from customers on a regular basis: is what is it? What are the hits to the database compared to the LLM? And it's not even a rounding error. It's a fraction of a second to do that query retrieval. But actually the long tent, or the long pole in the tent, is depending on the LLM you're using, pushing it out to the LLM and then getting that response. And then that just leads into the token count. If you're using a hosted LLM that's charging by the token, this is going to be very important for you. In our tool, users can turn on and off grounding, and then when it's grounded, they can have between 0 and 10 pieces of context. Right now, most of the context is in the 300 to 500 range for number of tokens, and so you can see that makes a lot of sense here, where we have, we do have the majority of our calls are in that kind of 1 to 4,000 range. But as the conversations, we are using one of the memory chains provided by LangChain. So as the conversations evolve, that actual payload of summarized documentation, as well as the questions and answers, does start to add up. And so, we do see conversations that have 8, 9, 10 turns. You can quickly see the latency, and then also the number of tokens that are being passed back and forth from the LLM. And so one of our colleagues is, we're looking at a caching layer or some other ways to make those calls a little bit more efficiency, just making sure we keep the cost and the latency overall down, so that the users want to use the tool, and they're not going to be asking a question and then going to get a cup of coffee because the response takes so long. And these are things that we didn't think about initially, but as we've gotten more usage and as we're building the tool, we're starting to take into account these other factors that are going to be important with any sort of production application. And so that was just kind of 2 examples of how we're taking a look at the data, which is it is pretty dense. It's good data, but it's really dense. So you'll definitely want some sort of a tool. There are some pieces on Langsmith that can help you analyze it, but you probably want your own tool to analyze it as well. And for us, because we're with Neo4j, graphs are everywhere. Every conversation with an LLM is a graph, and the logs of these conversations are obviously also graphs. In fact, one of my first, I worked as a security engineer in a prior part of my career. We were building graphs out of logs, and that's one of the most common use cases we see among our customers. So, why not take these Langsmith logs and turn them into a graph? And this is a very, very simple version of something that we have in development, kind of a personal tool we're building out. But the idea of, you have a session and then you have the trace, and in Langsmith terms, a trace is kind of the entire question and the question and the response. Everything you send to, it would be a user asking a question, and it's everything that's going on under the hood. And so a trace is built up of multiple runs. In our case, it's typically just 2 runs. It's the it's getting the context and summarizing it, and then passing it to the LLM for the question and answering. And so a run can have 1 or more children. And this is where, as we get more sophisticated applications, we build in agents. 1 run could have 1, 2, 3, 4, 5, 6 steps, each of which will be kind of just chained together in that parent-child type relationship. And then we're looking at, okay, what are the inputs to a specific run, and what are the outputs to a specific run? And is that something that's shared? Do we see duplicates of that? It's something that we want to analyze. There's going to be different different labels, different properties on these nodes, and then how do we trace this all back to our underlying logging that we showed earlier in the graph. And so kind of we're figuring out what would be the ways that we can incorporate, whether it's Langsmith or weights and biases or other logging data, into what we're already doing now with our existing logging. Nothing, it's nothing official. It's just something that we're exploring because we're seeing the value of bringing all of this together into a graph. And so with that, those are kind of the key topics that we were looking to cover for this session. And we'll quickly just go ahead and we can go ahead and just touch on some of the original takeaways that we had. Again, as you're working on a POC and looking at maybe it's going to take the next step from a POC, you want to work towards building an app that's viable for both today and tomorrow. And so, as we showed, kind of get out of the notebooks or get out of that early development into something that's going to be able to scale across a larger team and across users. Get that real world usage. Get to that point where other people can use your app as quick or your POC as quickly as possible, because that information is so valuable to see how are users using it, what's the feedback, what's working, what's not working, what are the features that or the data that you wish they wish it had. And as we've shown here, knowledge graphs are really flexible, really key parts of the architecture, both from providing accurate and complete grounding to logging to also providing visibility into how the LLM is working and responding. And just make sure you're building in that logging function, whether it's something that you build in-house internally, you use a outside service, have that logging, because that information is so incredibly valuable for it's going to be valuable in the future if your app moves into production and you're going to have to do it for regulatory or compliance purposes, as well as understanding what's going on under the hood and how, what's working, what's not, where can you improve your app, and how can that inform your roadmap for development. Alexander, I think, I think Alex had some internet issues, but Alexander, anything else you want to add? I know you talked a lot about the data engineering in the background, but any other key takeaways that we want to close with?
I think really, from my perspective, we're really leveraging the power of knowledge graphs, right? And their ability to coalesce a lot of these data sources into kind of a single entity, right? So, again, the fact that we're able to bring in all of this data really easily and connect it, I think is quite powerful from my perspective, right? And the ability to kind of drill into, the metadata around your application is really valuable, like you've been saying, Dan. So I don't know if I really have anything else to add beyond that, but I just think it's something I've been thinking about, right? As we add new data sources, I just think of how much easier this is to do than something that's a little bit more traditional, right? So.
Yeah, and you and I work together on an almost daily basis, and we're seeing the same thing with the customers we're working with. It's, they started with something maybe open source or free and easy, and they're looking it's not meeting the needs. We're seeing that. I don't even want to call it Gen AI 2.0, but it's the next wave, and it's not just us. It's the big clouds. It's Gartner. It's others showing that knowledge graphs are going to be a really important part of this. And we've seen that in developing our own apps. We see that in working with customers all the time. This comes up in almost every conversation with customers. It is that power and the flexibility to leverage existing knowledge graphs, as well as ones that are custom built for a RAG application, to bring all those different pieces of data together. And that's absolutely, we're seeing it every day, and it's something that I think is just going to continue growing and building momentum. The last thing, I know these are, Allison and Jennifer and the team have been sharing a couple of these resources in the chat, but a couple things we wanted to highlight. Obviously, the Gen AI ecosystem page, our colleagues in Neo4j Labs and DevRel are doing a great job building and just almost on a daily basis updating this page with new content. We have a lot of colleagues, Tomasz, Jonathan, others, who are writing great articles, great thought leadership about this. Jesus with the Going Meta series. And so this kind of is your one-stop shop for demos, code repos, how we integrate with the orchestration libraries, videos, tutorials, everything that you would want to get started. We have the Needle Starter Kit. It's actually on the same Neo4j Labs page that Alexander referenced earlier. Just a lot of great tools to build a front end if you want to build something that's has a little bit of a graphy flair to it. We also have the Neo4j developer blog, and that's where, again, a lot of our colleagues, Alex Gilmore, others have written, Kumar have written a lot of great articles, and just sharing like what they're doing, experimenting, and how they're using and learning from this. And then finally, Jesus and Alex, the Going Meta YouTube series every month. I think it's the first Tuesday of the month, if I'm correct. Great session 2 weeks ago, even about the groundbreaking paper where having that ontology on top of a relational data set really improved how it was able to generate SQL code that Jesus then replicated using Neo4j and Cypher code. So a lot of really great content there. There's just, if you're at all curious about like, hey, could a knowledge graph work? How would I want to use a knowledge graph to build out a Gen AI app? We just have a plethora of information available from all of our colleagues. So we're glad that this could be a part of it as well. And so with that, that's kind of what we have for the formal presentation. Alex, any other questions from the chat or anything else we want to touch on before
I have one more question here in chat from Adrian, but open invitation obviously while we read that and look into that. If you have any other question, any comments, then now is your time to get that out of your system. Otherwise, you can obviously later on reach us on our community forums or on our Discord server, where there is an open engagement and open discussions on all these topics. But if something is in your head right now, then just type away. But yeah, Adrian asks, do you have insights on how certain engineering/architecture, meaning knowledge graphs, works best or not the best for interacting with given LLMs? Are there any general or specific takeaways?
So how they interact best with the LLMs? I think that's a good question. I think there's really two pieces of it. From just building a RAG application, we use LangChain. We obviously have integrations with Llama Index and Haystack and the others as well. And so from the actual perspective of how the Neo4j graph interacts with the LLM, I think it's pretty agnostic. In some of the recent updates to Cypher and Neo4j, our colleagues have actually early on, you needed to use APOC or APOC extended if you wanted to call the LLM, say, to generate embeddings. If you wanted to do that directly from Cypher, you needed to call APOC. Now that's actually, all of that's getting built into Cypher. And so there's now almost, I think every release cycle, there's new features in Cypher to just make it easier and faster to integrate with the LLMs. And so from that perspective, it's pretty agnostic, whether it might be something that's hosted by the cloud providers or maybe running like an open source model that's running locally. I don't think it doesn't really matter. But I think the broader question, what I really like about this is, how does a knowledge graph make retrieval of the most accurate, complete information easier on the overall application? And that's what we're really seeing is, if you're chunking your data in a vector index, they're just kind of, I don't want to say random pieces of text, but it's just small little snippets of text or code or structured, unstructured data. That data does have relationships. That data is connected to each other, and how your data is connected much better than the LLM does. And so if you're able to construct that knowledge graph, and this is what Alex, you and Jesus covered just I think last week or 2 weeks ago, having that a knowledge graph explains how these pieces of information are connected to each other in a very real world way. And so the users of your application are not going to ask their question using column titles from a SQL database, and they're not going to say, in this table, this column, I need this information, and I want you to connect it to this and show that. Yeah, it would be great, but they're not going to do that. It's just not going to happen. And so an ontology or just the relationships in a knowledge graph it explains how, hey, I have a customer. This customer has an address. That address is in the city. They have this phone number. They purchased these products. That's all encoded in the database. And so it makes it much easier to pull and connect that information in a way that's interpretable by the LLM. We don't want the LLM kind of piecing different pieces of a relational database together. I've worked at a lot of the big tech, I've worked at a bunch of different places. The columns in a relational database and the table names kind of make sense, but they often don't, and they're not using the same terminology that the business user is going to use. And so having that all encoded into a knowledge graph using the business language makes it so much easier to have accurate, complete information. And so in that case, it's a much better integration with the LLM, because what we're seeing is, LLMs are good at doing a lot of things, but you don't want to overload them, or you need to break it up into smaller steps. And so if you can take that burden off of the LLM, it can focus on just synthesizing the information and putting together a really high quality answer. And so the knowledge graph does a lot of that work. It connects the data. It lets you specify how your data is connected, and you're going to be much better at that and much better able to describe that than the LLM is going to be figuring it out on the fly, generating a response in 10 seconds or less. And so that's where, so from the orchestration layer, I think it's pretty agnostic, but from the actual data itself, the knowledge graph does a vastly superior job, and we're seeing that, there's just more evidence coming out on that on almost a daily basis.
Yeah. Cool. Another question comes in from Laszlo. He asks, how do you decide to start a query at question node or summary child node? Both lead to the parent, right?
Yeah. No, that's a really good question, and that's something that you build into the, in the kind of in the code under the hood. You can specify when you do the initial query, you'll specify on what it's going to match on, and so you can match on whether it's a question, a question, a child, a text, whatever terminology you're using. When you perform that initial nearest neighbor search, so just like the other databases, when you're building a LLM or building a RAG app, Neo4j has implemented approximate nearest neighbors, which is it's the same algorithm most other databases are using, and so that will give you kind of the initial nodes that it matches on, and you can specify how many it's going to match on. That's one of the parameters that are built into the code, and so you can specify what type of nodes that's going to be. Like what are you going to want to initially match on, and those are going to be the nodes that have the vector embeddings that are indexed in the database. We have the vector index, again, just like everyone else does. And so it can be a chunk, or it can be a question, or it can be whatever you want. And then from there, you can build in this case, you can have some hard-coded cipher where, effectively, if you match on a child, traverse up and pull down the parent, or if you match on a question, traverse up, pull on the parent. And that's a very, very very simple traversal. It could easily expand into navigate up. If you have an ontology or you have some terms, you might navigate up and grab some more broader context. These are things that we have on our roadmap to build. I know Jesus demonstrates it in going meta when he actually shows the ontologies. And we actually use it, when we have a customer who has a real world knowledge graph, we're specifying on what we're going to match on. And then whether it's using LangChain or other code, you have a built-in traversal that says, okay, we're going to navigate up and bring in the broader surrounding context and bring all of that back. So for, say we're matching for like a recommender system, you're matching on customer purchases. Hey, we're going to match on the top 5 purchases. And then from there, you're going to pull up everything else that customer has purchased and see, okay, what do we want to do for a recommendation, for instance? So it's that kind of that anchor and traversal that applies just like it does for a lot of other Neo4j use cases.
Yeah. We showed this in a previous episode, like you said. So if you want to know more about this, then check out the Going Meta series. I think it was not the last one, but the one before that, where we looked into that.
Yeah.
But definitely check it out. We can, you can find a bit more information there on how it's exemplarily done.
And that's all the code repos and everything are provided as well. There's a lot of really, really good that's kind of unofficial documentation on Jesus's GitHub, but it's
Yeah.
really good. Like, he does a outstanding job with it.
Yeah.
So.
Social media IO app asks, that's a cool username. We are building a knowledge graph in the healthcare space where users can search for treatment information. Information is coming from PubMed, clinical trials, and other public and private database. We are importing the mesh ontology. How do you see knowledge graph working with an ontology such as mesh? I guess, we kind of talked a little bit about this as well. So it's a bit specific now. I don't know if you are aware of what mesh is.
So I'm actually not. I would honestly, that would be something where reach out to, if you're working with someone at Neo4j, reach out, or I think specifically for ontologies, I'm going to, with a smile, kick it over to Jesus and Going Meta. That's honestly, that's his world. And I would, I have some familiarity with ontologies, obviously, but it's getting into very specific ontologies. I know there's across a lot of different industries, and that's the world, honestly, Jesus, or we actually have other colleagues who are real experts in that area. So my recommendation would be to reach out to one of us directly, or through someone you're working with at Neo4j, and we can help get you connected with the right resources.
So they continue medical subject headings. That is how PubMed and clinical trials are organized and annotated. It's like an ontology, I guess, for the life sciences. So I mean, I agree with what you just said, Daniel. We have a couple of experts in house. So if you want to reach out to anybody at Neo4j, then, or if you have already maybe an established connection with somebody, then please let them know, and then they can refer you. We have, if you want to, research on your own a little bit, and definitely Going Meta is one of those where you just look into the last couple of episodes. We talked about,
I think it was 22 or 23. Yeah, like a real recent episode. You actually built it. It's completely built into this. It's a different ontology, but it's
exactly,
the same
it follows the same principle. If you are wondering how somebody else did it, or how to see what else there is, then you can check out a project called BioCipher, which is a ontology knowledge graph builder system that also uses a couple of outside sources like PubMed and others to look at the data, look at the structure, and combine it with your own data, and kind of like create a knowledge graph out of it with semantics, ontologies, and some other data sources combined. So I'll try to find this quickly and see if I can share that link in. Here it is in the chat. Yeah.
No, thank you. I didn't know about that as well. Thanks for pulling that in.
So that's it here. So that's something interesting. We did Sebastian Lobentanzer is from the University of Heidelberg. He's the head behind this. If you look for him on a notes last year's notes session, then you find BioCipher talk, and I had him as a guest as well during my community sessions sometimes a couple months ago.
Nice.
Yeah,
that's awesome. That's cool. Thank you.
Yeah. I had one question, maybe still is, you said, you moved, it took you a little bit of getting around this notion of moving away from Jupyter Notebooks over to a different way of working, different way of developing actually in this space. Was this a very hard shift for you, or does this now make more sense in terms of how to develop with LLMs in mind, or is this more like something that came very naturally, and it just feels like, okay, this is actually how it's done, and then feels even easier to do instead of the notebooks you used to?
It's definitely a shift, and actually, I know, unfortunately, Alex Gilmore, who helped with it, it sounds like there's construction that actually cut his internet access, so he wasn't able to jump back on. Perfect timing for that. So. But I don't know, Alexander, if you want to jump in as well for this. I know you definitely have more of a developer background. Like I come from the data science world, and so it's what's intuitive for me, but I also know it is very much not production. Versus I know you have a little bit more of that developer background, so it is more. It's not two worlds clashing at all. It's more just understanding the pros and cons of each. Like, what do you think about that?
Yeah, I think that's definitely accurate, right? And I think you're being generous in your description of me as a developer, right? I can hack things together for sure. I guess to give everybody on this call context, it took us probably 2 months, right, of side work to get this stood up. You know, and that's
we all have day jobs, so it's this has been a hobby, passion.
So
project.
very, you know, we got it spun up fairly quickly, right? Like none of this was rocket science from my perspective, right?
Yeah.
It's just about kind of getting the key components that we talked about in place. But you know, again, the implementation details on each component are pretty straightforward from my perspective, right? There's really only a couple moving pieces. It's just the front end code, the back end code to communicate to the LLM and Neo4j, right? So pretty straightforward.
And I think for depending on your background, it's whether you're of a software engineering background or data science background or some other background, it serves you really well. Like for me, it's getting me out of my comfort zone. 90% of the code I've written across my career has been probably notebook based. There's good and bad to that, but it's, you know, even for me, I wanted to learn more about the, you know, I don't have that background. I don't have like a software engineering or CS degree. And so I wanted to learn more of that because it's just not experience I have, but I know how important it is for building kind of anything that scales beyond, you know, hacking together some notebooks. And so that's where, you know, I know Alex has shared with me, and we've shared with, you know, we've both learned so much from Alexander and some of our other colleagues in just doing this, you know, and it's not easy. It's out of your comfort zone, but it's really valuable. And so if you have that background, it's just understanding there's different ways to attack a problem versus like when we want to take a look, like we started analyzing the lengths with data, that is a very good use case for a notebook and maybe building a dashboard or, you know, kind of more data analysis type tools. And so it's just knowing there's so many different tools in the toolbox, which one makes the most sense. And this isn't a one ring to rule them all situation. It's, you know, different tools have different applications, and just being open to that and being open to learn different tools because the technology is changing so quickly.
And I guess adding to that too, like I'd imagine, you know, anybody that's interested in developing a RAG application on this call, right, they're probably going to have kind of a similar path to what we had, right, where, you know, you probably have a familiarity with Neo4j and you have a, you know, kind of a data background. You might know Python, right? And you saw how far we could take that, just having kind of those that skill set, right? We're able to get, you know, basically kind of an initial proof of concept implemented in the notebooks. And then we're able to take that even a step further and go to kind of an MVP style application with the Streamlit, right? We're still able to kind of do that with all within our skill set of just Python, right? Or our data backgrounds.
Yeah.
And then like once you're able to kind of communicate the value, you know, maybe to some stakeholders, maybe to some colleagues, you can pull in some additional resources, people that, you know, might have a little bit more of that development background. But again, like if you're using like a lot of the technologies that we use during this, things like you know, Cloud Run on GCP or like, you know, those React component libraries that we used, it's still abstracting a lot of the coding away from you. You're just doing like a lot of basically, you know, copy pasting of code somebody else wrote, right? And it's like assembling kind of Legos almost, right? So pretty straightforward.
Yeah, we are not using this is not written in assembly language or anything like that, thank goodness. So
it's not rocket science for sure.
Yeah.
Cool. I think with that we almost already answered Neil's follow-up questions. Kind of, if this is all new to you, would you imitate your development path, so from notebooks to Streamlit to React, or would you start differently if you were to start from, you know, basically zero?
I think that
that's a good
kind of
question.
depends on.
Yeah, go. Yeah, I was gonna say, Alexander.
Yeah,
what
I
do you
think
think?
that kind of depends on your skill set, right? Like, if you're a rock star and you know all of these skills, you know, go straight to React, go straight to the cloud services, right? But if you're, you know, kind of like us, right, where you're more in the data, you know, you might be a data analyst, data scientist, data engineer. You might be somebody that just works with Neo4j, right? Like then it probably makes sense to get to the MVP, build on something like Streamlit that abstracts away, you know, a lot of the complex kind of under the hood, you know, details that you need to get, you know, a production application deployed, right? That's kind of my perspective on things.
I would agree with that and really take the path of least resistance for you, whatever that is. When I was, when I got this started, this was back in June or so last summer. So the LLM space was rapidly emerging. And so like for me, it was what could I find really good tutorials or examples? And then how could I turn that and implement it on my own? And that was like, and at that point, there really wasn't even a lot about implementing this in Neo4j. It was a couple of us had been toying with it internally, but the public facing resources it was so early that they weren't even there yet. And so just finding what could I find early, use, replicate, understand, and kind of make it my own. And that's how quickly, that's how, it was ugly, but it worked. And I was able to, like, for me, what was really valuable was I could show, and these were LLMs from a year ago, they didn't have updated information about our graph data science library. So I'd actually seen some customers get some really, really bad responses from some of the LLMs that had their training data was 2 years old, and there had been so many changes. And so I had the question I was always using was, what are the most important hyperparameters for the FastRP embedding algorithm? And I got some horrific responses. But what I could do is side by side, I showed the ungrounded and the grounded answer. And I actually just copied and pasted the text into a PowerPoint. But I showed that to, I wasn't even pulling up the notebook. I was showing that to some of my colleagues in my leadership. And it was like, oh, wow, that's big improvement. Let's keep this going. And so it was that early quick win that, then Alex Gilmore got involved, and then Alexander and some others got involved. But it was getting to that really, really quick win early on by kind of whatever means possible. So even if it's 4 ugly notebooks.
Yeah. I think you can quickly see how much benefit you get from adding a knowledge graph to that kind of interaction with an LLM, but just adding that context and adding that baseline. So yeah, Neil, build a knowledge base and dashboards. So if you're looking into dashboards, maybe I can also plug in here the Neo Dash tool. That is something that helps you also along the way. There is also some integration with LLMs and for that. So I guess you kind of can get started a little bit easier if you look at that and use that to help out with the front end.
And that's something we covered actually on the first presentation back in October. We did have a Neo Dash dashboard for the original tool. We just didn't. We were just focusing on different topics here, so we didn't include it today.
Yeah, makes sense. Cool. We had one more question from Mason here. He's building a knowledge graph for library cataloging. He would like to know, where can I get a structured data with information I need to build nodes, relationships, and properties? So I guess you're looking for a data set. Is that what I'm reading here? I mean,
it sounds like it. Kaggle's always a good place to start. I think it is. What is it? There's one of the University of California schools has a great data. Hugging Face has become kind of a go-to for data sets right now. I think Sebastian Roschka is, kind of one of the. He's a deep learning author, writer, written about a bunch of books and stuff. I think he has a catalog of data sets. I don't know specifically for that type of data set, but I would typically start with, I don't want to say it's not UC Irvine maybe, or Kaggle or Hugging Face would probably be where I would start. Or also there's a lot of guides now on using an LLM to generate a training or kind of a synthetic data set as well. If you provide it the details, you can actually have the LLM generate, 10,000 records pretty easily.
Then at least you get something synthetic and to play around with it to see where it's going.
There's no usage issues, no licensing.
Exactly.
Yeah.
But Kaggle is a good place, exactly. And then maybe maybe your university or something local library provides something, has a catalog of their records available as a CSV file or as something. You can always ask.
Depending on where you're at, that would be considered a public data set too, as well. Like the library catalog, they could, if it's like a research or a PhD project or like a master's thesis or whatever, they might just share it with you, and you could build them a really cool tool that they could use after.
Or you try and look at museums. So often they have a digital catalog of their exhibits, and it's kind of like similar approach, right? I mean, if you either connecting books or connecting arts pieces of art, from a baseline here, I think that works similar, but just the records will be different.
Yeah. By chance, have you seen that on a Going Meta episode?
No.
Actually, he did. No, Jesus used that.
Oh yeah, true. You're right. Yes, we did that. Yeah,
he did. When you said that, I was thinking of an
yeah,
episode a couple months back.
Yeah, we looked at the museum, the Met, in New York.
In London, I think.
The what's it called? Not the Metropolitan Museum. Yeah, in New York, right? I think that's the British Museum.
Yeah, it's one of those. Yeah, one of the big
also,
ones.
Yeah, so they have data sets available. We did lots of things on Going Meta. Yeah, I kind of like.
Actually, that does remind me. Maybe even at least in America, the Library of Congress could actually has a lot of public records. They might be available. They might not be. I think it's data.gov or something is the U.S. government's public data set, and there could be something for the Library of Congress as well. It could be really useful. So.
And then another question, more of a comment from Dalitz. I'm building a knowledge graph, not for raw information, but for reasoning. Database is algorithms of how to solve thousands of medical problems, similar to the other use case, I guess, a little bit. And I'm building a knowledge graph that the LLM will use to synthesize new solutions. Having the knowledge is one thing, but knowing how to implement it in appropriate reasoning steps is key. So, yeah, I think that's...
Ooh, that's a good question. I can take a shot at it. I don't know, Alexander, if that's if you've seen this, but I think it actually is getting a little bit more real world, where it's almost a temporal in the fact that it would be this takes place after, like it would be almost like I could see step one relationship, next step 2, next step. You're building it actually is probably really similar to what LangChain is doing with LangGraph, where they're actually using DAGs to specify the steps that an agent should follow. So do this, then this, then this, then this. It's not something. It's something that I'm actually planning to start. I want to work on a little bit more in the future. But this is how they're specifying how you it's how they're describing the steps that an algorithm or an agent should take when it's solving a problem. It could be synthesize the data, then, okay, you need me to book a trip. I'm going to go here. I'm going to book a flight. Then I'm going to book a hotel. Then I'm going to book a car or something. Like it's the actual logical steps that would need to be taken. And so I see that like almost like a next type relationship. What do you think, Alexander?
Yeah. I mean, I agree with that. I guess something that I like to keep in mind too is like just kind of the order of operations here. So you construct a knowledge graph, right? And in that knowledge graph, like we have nodes that have the like embeddings that we pre-processed and wrote to that knowledge graph, and we're using vector index for search on. But you can also use like the GDS library, right? And kind of post-process things and come up with some features, right, that are that could be used for inference maybe down the line. So that's also something to keep in mind, I would say, is kind of like the ability to kind of post-process and use kind of our algorithms, right, to again, kind of do some feature engineering in the graph. So yeah, I guess that's something I would also keep in mind. Like when I was listening to the use case, it definitely sounds like there could be some chains, like it could be more of a journey, or yeah, you could maybe use the GDS library to like infer new relationships potentially. Just this is kind of outside the scope of the LLM, and then you could also, feed that information back into the LLM as part of prompt engineering.
It would basically be, I think that's a really good point to highlight with GDS. It would be like, what would be the next steps to take? And then, that would be whether you're using LangChain or something, like, again, what do you match on? And then what cipher is it executed, whether it's going to be dynamically generated, which is kind of it's kind of a work in progress, or is it actual, like a lot of these use cases, all you need is hard-coded cipher. You know the graph, the nodes and relationships. And so you can traverse it knowing what already exists. And those could be derived relationships from GDS, or ones that you hard code, specifying the next steps to take. And then even with the GDS algorithms, we have the entire pathfinding library, which you could pre-execute or pre-describe, like, hey, if I match here, like what are all the different paths from point A to point B, and mapping those out. And again, it's kind of the idea of taking, there's a lot we can do to help the LLMs. Like, it doesn't all have to be done by the LLM. We can use a graph, we can use relationships to either point it in the right direction or specify the path that it should take. I have this problem, okay, these are the steps that I should take because the relationships are already objects in the database. All I have to do is traverse them.
Yeah, cool. I think there's one more question from Rob. He says, curious about testing strategy for this solution. I can imagine there are a variety of unit integration tests for both front end and back end code. But what about testing the LLMs and your code? And then he has a follow-up to that. Is there some testing framework in place to catch code that may have unintentionally improved or degraded response quality from the LLMs?
That's a very good question. I'll start. I know from the code side, I know, Alexander, you can probably touch on what we've done there, kind of how we're, that's where a lot of our actually Pydantic comes in as well. But from actually evaluating the LLMs, that's a really emerging area. Langsmith has some of the capabilities in there. Like, there's going to be a lot of tools that you can flag answers. You can match them up against like model response, like not against optimal responses that might be like pre-generated or pre-written, and just use, you basically, it's not a fuzzy match, but there's different algorithms in like BERT and others where you can compare the quality of responses and say, hey, how does this if I ask, say, a response to OpenAI, Gemini, and Llama, how do I compare the 3 responses to the one that I think is the best? And that's a lot of that human in the loop feedback. So there's a lot of work being done on how do you judge the quality of the responses, and then you can get into the precision and the recall of like, did it pull in the right or the optimal data sources? That's we're getting into that with our integration of Langsmith, and kind of going to be building that out going forward. So from the LLM side, there's a lot of tools out there, and I think even some of the cloud platforms are building them in. LangChain has it, and others. But I don't know, Alexander, from a code perspective, I know we use Pydantic, but what else have we done, like, or what do we have like even on our roadmap? Because it's kind of a side project for all of us.
Yeah, I mean, I'd say the big thing, like from a code perspective, yeah, Pydantic, right? Using type languages, but I think like the core of the question was really, using Langsmith, right? Like using that to kind of evaluate the accuracy of the responses, right? That kind of felt like more of the core of the question, as opposed to, what do we do in the code itself? I think something that I've been personally interested in is, perhaps visualizing maybe what's happening a little bit under the hood, right? Like being able to visualize the actual clusters of documents that we end up retrieving here, like directly in the application, I think would be pretty interesting, right? So you can actually see like, okay, these are the clusters or these are the documents, right, that are actually behind this answer. I think that's something I really want to explore kind of in our further iterations here in the next month or two, because I think that's really powerful. Like something, I think a big complaint with a lot of, kind of the more traditional approaches with doing vector search, like using vector databases, right, is it's very much a black box. There's no explainability with the data. And I think using the knowledge graph, kind of pulls back the sheets a little bit, right? I think there's an opportunity to kind of improve that observability and that explainability to the end user through the use of visualizations.
And one other thing we didn't even really touch on it this time, but is just having a little radio, like we just have an easy way for the user to provide feedback. If you use ChatGPT or Gemini or some of the others, you see this is built in. We have it built in as well, where, and what we ask is as much as possible for users, like rate the response. Is it thumbs up, thumbs down? And then there's even options to provide a description of like, okay, if this was a thumbs down answer, why, whether it's something they can click on or a free text field of, hey, it was inaccurate, it was incomplete, it wasn't good. And so going in and Langsmith does this. We have it in our Neo4j based logging, but just start getting users to use the product, and then asking it questions you'd never thought of, or using it in ways you'd never thought of, and being able to rate that. That's honestly, like, that's the low hanging fruit. That's the easiest way to get started, and just say, you can go back and after a week or a month say, okay, I want to see all the thumbs up answers and I want to see all the thumbs down answers. And you'll quickly see trends on why some did better than others.
Yeah. Alison comments in chat as well. She likes deepchecks.com for evaluation. So.
Okay. No, that's right. That's one I hadn't seen before. So thank you.
Another one to look at. One more question from Neil. Do you have any examples of how the architecture might be used for translation?
Ooh. Not off the top of my head. That's interesting. That's an interesting application of this that I hadn't even thought about before. I don't think I have anything. I would have to do more research on that. And just kind of develop out the use case a little bit more.
Cool. I think with that we are at the end of the questions, end of the line also for the time we have almost. So I think we can slowly wrap it up for today. Thank you, Daniel. Thank you, Alexander and Alex, for presenting today, for taking the time to guide us through the work you did and all the amazing, specifically the knowledge sharing today of what you learned, your takeaways, your conclusions, your tips and tricks for, if somebody is on this path or starts this path now, just to avoid what not to do. Yeah. So I think that's super helpful, and it's a good way of helping people on their way.
Yeah. And thank you as always, being an outstanding host, and Allison and Jennifer for also helping us out with the chat. Since when we were focusing here, I saw a lot of chat activity and a lot of responses that were really helpful as well. So thank you to the entire
Absolutely.
team.
Thank you, Allison and Jennifer as well. Thank you for spending now almost 2 hours with us on this topic, for your comments, for your questions. Thank you all for your lovely words in chat. I see that we all see that, we read that. So great that you appreciate this as well, and is helpful for you. So thank you for that. If you want to continue the journey, then I'd like to guide you to a couple of resources that are available at Neo4j. One is the I think aforementioned Neo4j community forum and the Neo4j Discord server. If you have questions, if you have comments, anything, you can go there and interact with the community. If you are on your journey to learn more of Neo4j, if you want to dive into either Neo4j in general, but also talk about, learn about how to work with Gen AI and how to build your own chatbot, maybe, then I would like to make you aware of the Graph Academy that has a lot of free courses. Recently, we just added another one on vectors and on the way how to work with those. So if that is interesting to you, then check it out and enroll for free. These courses are all free of charge, and you can just submit as a login and just play around with those. And if you are wanted to learn a little bit more, then I'd like to invite you to this final and upcoming workshop that's happening next week, where we talk about geospatial data analytics with graphs and the PyData ecosystem. That is happening on the 26th of March, so that's the next Tuesday. With that, I think we're closing it for today. Again, thank you for watching. Thank you for your time. Thank you for your questions. Thank you, Daniel, Alex, and Alex, for sticking around and for helping out and for presenting the great content today. And I wish you all a good rest of your day, rest of your week, and I hope to see you soon again at one of these live streams in the future.
Thanks, Alex.
Thank you again.
Thank you.
Take care.
Bye-bye.